10.8 notes, vectors. This is page 2. And so a lot of terminology. You want to make sure that you are using the terminology correctly so that as you are asked for something, you know specifically what you're looking for. We're going to talk about vectors in a couple of different ways, okay? And so, like we said on page 1, a vector is a directed line segment, which means direction matters. It's different if I'm going from home to the school versus if I'm going from the school to home. I've got different reasons for doing that, and different things happen when I get there. It's the same thing here with vectors. Direction is important. So we have a position vector started at 0, 0. It's identified by its terminal point. Be careful, you don't want to write that terminal point as an ordered pair when we are talking about how we write the vector. We want to make sure that we've always got these angled brackets to show that it's a vector and we are moving in a certain direction, certain amount in a certain direction. So A here, we've got this vector drawn. Point A is the initial point, so we're going to go ahead and just geometrically refer to some of the terminology from the first page. Point B is the terminal point. Okay. Oh, so now we have two A's. A sub 1. Draw the horizontal and vertical components of AB. So our horizontal component is just same thing I did on the graph. It's how far I go to the left or the right. My vertical component, how far I move up or down. Okay. Once I do that, because I'm moving completely horizontally or completely vertically, I create a right triangle. Just going to take us back to using the stuff that we used in our right triangle trig. Okay. So if we have ordered pairs, and so let's see if we can match these up, we are going to we're going to label A as the point x sub 1, y sub 1. Go ahead and label B as the point x sub 2, y sub 2. And I can use those points now to find the distance horizontally and vertically, okay? So to move this direction here along the horizontal, I'm going from the point x sub 1 to the point x sub 2, which means that the distance between them is x sub 2 minus x sub 1. Direction here is going to matter. And when we used right triangles in the Pythagorean theorem, it didn't really matter which way we subtracted those because we were going to just square it anyway. Here, the direction does matter. We have a fixed start, a fixed end. We want to make sure we are getting this in the right direction. So we are going to take our terminal point component minus our initial point component. And we can do the same thing with the y. This distance right here is going to be y sub 2 minus y sub 1. Nothing fancy. And when we use this with numbers, hopefully it'll make a little more sense. But now when we go down to B here, the component form that represents that vector is x sub 2 minus x sub 1, y sub 2 minus y sub 1. And that's going to be our angle bracket AB. Okay, that's going to tell us the distance we go left or right and the distance we go up or down. So to find the magnitude, it's going to look the same way. X sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And we're going to take the square root of that sum. Now, notice here, when I'm talking about magnitude, I've got these double bars. Sometimes you will see it that way. Sometimes you will see it as a single bar. So I'm going to write that down here. Absolute value, you guys, that's just the distance from 0, right? And that's exactly what we're doing. We're finding that straight line distance from 0 using that horizontal and vertical component. When we talk about a position vector, And the direction, we're going back to reference angles. We're talking about the angle that is made with the x-axis, okay? And specifically, it's going to be the angle that's made with 0. So we're going to talk about a position in terms of that angle with respect to 0, okay? So example 4 here, let us take a look at what we've got. We've got an initial point of -8, 1 and a terminal point of -2, -5. I'm going to start by just graphing that. So -8, 1, -2, -5. And there is my vector, okay? So we want magnitude and direction. So let's go ahead and find the position vector first. I'm not necessarily going to graph it on here. We don't have the room. I could. So I'm going to start by going, let's see, our terminal point is the -2 minus our -8. And for y, -5 minus 1. That gives us the position vector 6, -6. Angle, angle, angle. Okay. So to find our magnitude, let's label this mag. I'm going to call the vector v. It's the square root of the distance between the 2 points. You guys notice that we just cranked out that distance. So I'm just going to use the values from that position vector. I get square root of 36 plus 36, which is 72. We are definitely not going to crank this into a calculator and get a decimal equivalent. We want exact values. I can simplify this. We know that 72 is the square root of 36, or sorry, is 36 times 2. So I can pull that square root of 36 out, that's 6. And we get a magnitude or a length of the vector of 6 square roots of 2. Okay. The other thing it wants is the direction. And the direction, it tells us inverse tangent of b, which here is -6 over 6. So we're looking for the inverse tangent of 1, -1. Okay. And so think about inverse tangent. We've got to go back to when we talked about the inverse trig functions. Inverse tangent is only defined in quadrants 1 and 4. It's going to kick out that negative angle for us. So this is the inverse tangent of -1. I know that is -45 degrees. Okay, which means if I had a position vector, I'm looking at it right here. So I guess 1, 2, 3, 4, 5, 6, just barely cut it off. 1, 2, 3, 4, 5, 6. Okay. I want the angle made with the x-axis. Typically, it is a positive angle. So I've got -45 degrees plus 360. We're going to go all the way around once, and we get a direction of 315 degrees. Okay, I don't want that negative angle. I want that positive angle. Okay, so we have a magnitude or size of 6 square roots of 2. We have a direction of 315 degrees. And that is what we've been asked for. So here's our original vector. Here's our position vector. Even though it didn't ask for that, sometimes I like to graph that in there for reference. It makes it a little easier for me to see whether or not my direction is on mark or not.